4E, and in the 1, 2, 3, 6. Okay, so these are the series number for the Curtis controller. Why we are using Curtis controller? It is different from A5, that in A5 we don't get having a function of reprogrammable option or evaluate the parameters. But in Curtis, we are getting these features, so we can we don't use direct method to change the rotation of speed of motor, FOC techniques or DTC techniques. We are also indirectly correlate the operations of the motor through the induction through the Curtis controllers. Okay, so what is a Curtis? A Curtis is a significance model which we having a power of dual microprocessor logic architecture to provide improve the performance. Like in the controller, they having a sub 2 microprocessor. They are going to be operate for the input, and one is going to operate for the input output peripheral connections, and second is going to connect with all the data logistic features and the architecturing part of the sub peripheral or auxiliary components which are going to be connected with the CAN communication with the ECU and the PCU connections. Okay, so what we are getting an advanced part like the Curtis model of 1232E provide advanced control of AC induction motor performing in the vehicle traction drive or hydraulic pump duties offer a highest level of functional safeties. Okay, but in the Curtis we also get many of the offers like a word VCL. Okay, just like we having to define the rotation of speed of motor with the torque control or the precise of acceleration deceleration, but we can program it programming languages like VCL, vehicle controller language. Okay, we Curtis is going to offer us like a programmable function, indirect field orientation control, auto tuning function, dual drive functions, and configurations of CAN bus with the integrated system controls. So these types of major functions which we are getting with the Curtis controller. You have also seen that forklift. In the forklift is very useful and it is widely used from the past 20 years in the JCB company and the forklift OEM manufacturer companies to go for the pumping and the hydraulic system. Okay, so what the first thing comes in EVs when we are going to talk about how the controller is going to be operated. The major thing which come in our mind like VFD, variable frequency devices, which are going to control the AC controllers, and in that AC controllers we are moving towards the scalar or vector quality, and in the vector we are coming with the FOC or DTC, field oriented control, direct torque control, or somewhere there we are also moving with the PID controllers. But when we are getting a reprogrammable function or indirect function in some of the advanced type of controller, we are also relating each of the topics of to accelerate and deaccelerate the speed of the motor. Okay, so these types of the features, commandable options we are getting. And when I'm coming with the first topic of Curtis VCL, where we are getting a programmable and adjustable speed profiles of the motor with the helping of to set the parameters through the software. Okay, or we can say that this type of controller is kind similar to the embedded system, where having a combination of software as well as a hardware part to run the sufficient to deliver the power and to run all the power electronic component to with having MOSFETs, IGBT power electronic devices for the switching device and the efficient output. But again, when we are talking about software part, we are using one of the OEM manufactured, self OEM manufactured software 1314 PC programming station for this particular type of controller. Okay, so the vehicle control language is an easy to use the programming language that allow the vehicle to develop and write a powerful logic function to create a virtual system. So through the parameters changing, we are having a good command on our vehicle. As I mentioned that FOC, field oriented control, where we are going to vary the voltage frequency, so we can see that the output variation in the other side of motor, but somehow it is going to coordinate with the indirect field oriented system which we are getting in the Curtis. Okay, so we get a maximum possibility of torque and efficiency across the parameters changing in the software part. Okay, we are also getting a speed regulation, speed graduality in the optimized performance tuning of the function which we are getting from the Curtis auto tune method, where it is compatibility for the all type of AC motors. We can compatibility easily connect with all type of AC motors which we are preferring for the electric vehicles. Okay, dual drive versatile and customized option like dual drive function. This type of controllers are suitable for the dual drive of motor, as we always cover that why we are not why we are running with a single type of motor, and some of the OEM manufacturers like they are having also a dual type of motor. So to instead to apply a different controller to the each of motor, this Curtis controller is suitable to drive the motor for a dual function. Or we can say that this having a twin traction motor accessibility. Okay, to allow the current control on the application, safe operation, and the minimal tire wear. Okay, so this also offers a provide a 20 VCL configuration and the malfunctioning part of the data logistics. Then we come with the part of diagnosis and fault monitoring. It is very it is very difficult to identify the fault while when we are going for the operations, while when we are not getting the speed, while when we are going to how to improve the acceleration speed, deceleration speed, brake rate speed. So at that time, some the fault finding and the diagnosis part is very difficult. But if we are having an integration part with the Curtis controller, we are having a also accessibility for the diagnosis system of operation function of the motor. Like if we are using AC induction motor, so in that AC induction motor, the encoders, the sensors which we are there, so they can get the performance of their responses, and as per the responses, the heat, the temperatures, the thermostat sensor is also there in the motors that can examine all the angles and aspects to observe the performance of induction motor. Okay, so it is very easily to understand the diagnosis part and the fault monitoring function with the helping of Curtis controller to get a complete diagnosis of the input, output, and the feedback responses which we are getting from the auxiliary component, and as well as it will create a closed loop control system near about them. Okay, so we can examine each of the performance. I will show some parameters in upcoming slides. Okay, so what are the benefits we are getting? Like we are getting a fully command vehicle, a fully reprogrammable functions. So while even we are going to design any vehicle, we are more focusing on the top and some of the aerodynamics, rolling resistance, gradient force, the force against to moving the motion. So we are going to complete more focusing on that parameters, and to maintain the gradient angle. So how much power we are have to reach to give by the motor stop that so it can be able to give a high acceleration and high RPM. Okay, so to at the time of selection of motor, we are also getting complete explanation and examine of the performance. So we can change the power, or we can change the speed of the motor up to 8,000 RPM. Okay, from the function of Curtis AC induction motor. So these types of features, speeds, adoptions we are getting from the controller. As I hope many of you, some of them you know about the controller, some of you have not know about the controllers. But in every controller there are 5 basic wires. So let's talk about the pins, block diagram, architecturing of Curtis controller. So we can really understand and imagine the function and how the wiring connection should be there in the at present in the four wheeler of electric vehicle. So the first B1 plus B minus is a terminals from the positive and negative terminal from the battery to giving power supply, or we can say as a input wires to the controller. Okay. Along with that, in many of the Curtis controller, we have to connect fuses, contactors to give a power supply to maintain, from any fault or any protection. So we are using protection devices. Okay, but when we're talking about UVW, it's a channel wires which are going to be output wires for the phase winding. Okay, for the motor induction phase winding UVW. So in every controller you will see that five basic wires. Two are the positives and these are for the negative. These are the output wire. And along with that, we will find that we having 35 pins and each pins have different functions. Okay, in every controllers of the Curtis brand 1232, 1234, you will find this type of architecture, and they having 35 pins which are going to be communicate for the features for key switch, for auxiliary connection, for temperature sensor, for throttle, for wiper of the high potential of wiper, channel encoder wire, battery system, CAN communication, high data, high CAN, low CAN. These all these functions, driver functions, which we are getting and with the connection of from the 35 slots of pin. Okay, so this was one of the block diagram of Curtis 123E 32E. Okay, so I'm going to talk about each of the 40 pins. So you can see that from the key switch, we are going to start with the pin number 1 key switch, where key switch is going to be connected, and along with that second pin for the driver. So I'm starting with the right side. So from the first pin is going to be connected with the key switch. Second pin is going to be connected with the contactor for the to create a magnetic field in the contactor for to move NO to become NC, to become a NO to NC. Okay, so this is going to be connected with the contactor 13 and 6, pin number 6, and these are like driver 2, driver 3, driver 4. These are the wires from EM brake, pump, like I told that forklift, and the hydraulic pumps. These are also using for the specific function to control them, to run them. Okay, so to connect all these, so we need some protection devices. So to trigger them, to magnetic the protection device, we are using these coils. Okay, so you can see that these are for the separate driver and for the separate function connections. Then we talk about the input wires. B plus and B minus is the positive and negative terminal from the battery power supply. Okay, then the three output wires which are going to be connected with the AC induction motor. Then we having four wires, and these four wires where are going to be power supply with the 5 volt. We are having a Hall effect sensors, a two Hall effect sensor. Like in BLDC motor, in some of the motors we are having three sensors. But in the AC induction motors, with having a configuration with the Curtis, they are having two controller, channel A and channel B, where we also call as a position feedback, because it will from the sensor we are getting the exact position of rotor. Okay, so what was the purpose of sensor? To detect the position of rotor and give the response to the controller, and as per that response only the power should be delivered by the battery to the motor through the controller. Okay, so the main function of the part is to get the response from the encoder to rotate the motor. Okay, so again the topic, CAN high, CAN low. These wires are going to connect with the CAN communication from the data transmission for ECU controller. CAN high, CAN low also going for the charging function. Like when we are going to connect with CHAdeMO DC fast chargers, they are also having a priority lines. They are having single phase connections three-phase connections to charge the vehicle. So we are going to power supply the CAN high, CAN low signal, CAN ports for to them also. Okay. Then we are going to connect with the transmission part, and these serial port is going to connect with the driver circuit. Just like when we are going to integrate with the software part and hardware part, these four wires are going to transmit the data for the TX and receiving the data to change the performance of controller. So these four wires are the master wires where we are going to connect the controller with the software function. Okay. And also you can get the parameter display, when we are going to get a power or responses any of the further, so it can be connected with the display function also. So let's towards move toward the left side. In the left side you will find that all the emergency reverse braking system, interlock connections. These are the switch, like switch 4, switch 5, switch 6. These are the wire for the lift, just to like when we are going to connect the power supply to the pump. So to lift the body up, to lift the body down, for the upper zone, for high power torque is required to for that initial traction of motor. So we are giving a power supply to these connection from the switches. Okay. This is going to be connect for the motor connection forward and reverse. And again, one of the external future scope wire is given to connect for the switching devices. Okay, to command for the switching part of operations. Along with that, in AC induction motor, which we are using in EVs, we having a thermostat sensors along with the motor only. So to give that sensor power supply, and as per the some of the parameters are also there. If the if the sensor is going to be reach certain temperature, or if the temperature is going, like if the temperature is going to reach between a range from 40 to 85, in between of them it's going to be connected like 65. So whatever the drawback, like in that case how motor is going to be operate, if the temperature reach at that certain level, the motor RPM is going to be degraded, and it's come up to 500 RPM to 800 RPM only. Okay, so this was a range, and these type of functions are, and the algorithm is predefined functions which are there in the Curtis controller, which can save, which can cool down, which can help to cool down the induction motors. Along with that, to cool down the to you can say that it can help to improve the lifespan of the operation systems. Okay, so we are going to talk like I talk about like 5 pins, but along with the 5 pins we having. Okay, I forgot about these pins. What are the function of pins are there? Like after the temperature we are having these pins are going to be used for the acceleration, deceleration. Like we are using potentiometer in the electric vehicles. Major of cases we have used like electric throttles. In the electric throttles we are having bipolar linear hall effect sensor. Okay, linear hall effect sensors are there, and with the helping of magnetic variation, strong magnetic field, and low magnetic field, we can give a variation in the voltage, and we can operate the motor very quickly. Okay, but somehow in these types of complete circuit of controller, we are going to connect with the potentiometer throttles, where with the have it, you can understand or you can relate with it. It's a very variable rheostat. Okay, so with the helping of high rheostat, the voltage fluctuations, and when we are having a less potential of the rheostat, we will see that having a high voltage of output. Okay, the resistive load is inversely proportional to voltage, and as per that we are giving a variations to the vector quantity of the control of AC induction motor. So as per that we are going to command the complete operation of Curtis control. Okay, so these are the major pins. Like each pins are having some of their inner functions, some of their peripheral, like I explained about key switch, drivers which are using to operate for the particular device, like pump to contractor power supply, grounding connection, analog input to going to be connect with the serial bus converters, switching for the forward, reverse, for uplift, lower lift, all these functions, along with the throttle, high pot wiper, medium connections, along with that digital output, CAN controller connections, 12-volt output power supply, which is going to communicate with the data transmit, and a 5-volt output, which is going to communicate with the encoder, thermistor sensors, which are working on the low voltage power supply. Okay, so these types, all these port functions we are getting from this 35 pins channel. Okay, so from this 30 pin slots we are getting all these wires. I can show you in the pic also. Like this was a pic of Curtis controller where we are getting a power supply, 5 major wires like positive, negative, and these threes are the output wire UVW. Along with that, these pins are 35 pins, and each pins having different function and different operation to give a sufficient and efficient output to run the motor and full command on the AC induction motor. Along with that, we are going having a fuse connection. In some of them case, we are having a connection for the contactor as well as. Okay. So let's to move towards software part. I said that it's a part of like embedded system. So in the embedded system means they having a combination of software as well as hardware part for a specific real life orientation part, and as well for the general purposes. For specific purposes, we are using that. So in this software, we are using 1314 PC programming station. Okay. So I will show my screen. I will just on the software part. But in the software look like this. Okay. In the software, you will see that we having file communication channel view, but you have to connect the communication driver. This software look like it's developed by the OEM of Curtis only, but in the software you are can't going to relate, or you can't going to see the monitoring parameter diagnosis and current specification of the current specification of the complete operation, because of when you have not connected the driver. You have to connect the driver with the controller. They having one of the channel driver. Through the connection of driver only you are getting the all these parameters. Okay. So after going to connect to the channel driver, your screen is going to look like this. Okay, so you will get the parameters. You are getting a parameter of system information where you are getting the complete architecturing idea, as well as a complete software configurations. Along with that, the model specification, that what was the 2-minute RMS current rating, voltage variation, suitables, range for S2 60/30, safety functions. Okay, so these types of specific power features which and the particular functions of the model we are getting from that. Like it is suitable for model available for 175 ampere to 250 ampere, and output it can access output voltage of 24 to 80 volts system voltage, and current rating should be 175 ampere to 250 ampere. So it is suitable for that particular specific range. Okay, and as a different parameters, like they are having a different model 1 2 3 4 1 2 3 6, and EE or SE models, they having a slight difference, but the basic understanding was very similar to the each of the Curtis companies. Okay, so in that you can see that the second part is parameter. In the parameter you are getting some options, you can change the variations, and in upcoming slide I will explain some of the parameter as well as. Okay, and we are talking about monitor. In the monitor status you are going to see what are the complete performance of like complete operation of input, output, battery, motor RPM, motor temperature. If you are connecting a dual drive EV motor, then we are having what was the speed of first motor, what was the speed of second motor. Okay, So what was the RMS for to delivering the power supply? Okay. So what was the modulation depth, frequency, temperature of the controller? So these all performance you are getting, and you are getting some of the parameter data in the Curtis software. Well, when you are going to connect the Curtis controller with the driver to your PC or to your setup. Okay. So you can see that I have connected and I have taken some of the screenshots for to get particular variations and what was the predefined function, which function I'm using, which is not using. So what was the pulse modulation signals while when we're having the initial throttle, and what was the losses. Okay, so we are getting a 72%, minus 72%, and 3.64%. But I have connected in the negative terminal efficiencies connection and going to integrate the power supply. Okay, along with the motor RPM subsidiary, controller function, frequencies, all these parameters are can be examined and analyzed by the help of Curtis controller. So now I have showing you the connection configurations of the sum of the monitoring degrees of motor and controller only. In the motor, we are going like in the deceleration, or we are not given any throttle speed, we are getting 0 RPM, and the temperature is set to up to 200 degrees Celsius. If the motor is going to reach up to 200 degrees Celsius or near about 165 degrees Celsius, the motor is going to be shut. The power should be shut down through the controller, and the interlocking system is going to be on. Okay, and you can see that what was the current state of motor 1, motor 2, if it is a vehicle is going to be in the static position or dynamic position. As per that, the your complete specification should be monitored by the help of Curtis controller. Okay, so what was the current which is given by as per their load, because we are not going to run any appliances of the vehicle, but substantially the thermostat and some of the small amounts of power is going to supply to the each of the component. So it will be calculated like 1.3 ampere is going current is passing through the controller to any of the devices. Okay, so what was the main state, temperature, frequencies, all these parameters we are going to be examined easily with the help of this software. Okay, so before that I'm going to share like what are the parameters. So in this parameters we are going to, okay, so in that case we are going to, I will get back to you within 2 minutes. Okay. Sorry for the disturbance. I'm going to share my some of the parameters which we are going to reprogram, or to understand the concepts of what are the logical parameters which we are going to show, which we are going to see in the functions of parameter. Okay, so how we are going to change that and what was the range variations, I'm going to explain these topics. Okay, like we are having starting with the programming function temperature hot cutback. So in the temperature hot cutback parameter, we can give a ratio like it's about 600 RPM up to 800 RPM. In that case, if we set some temperature to the temperature control hot cutback, okay, if the temperature reach that, like it's starting from 45 degree to 200 degrees Celsius. If I going to connect that temperature in 65 degrees Celsius, okay, and if the while when we are going to run the electric vehicle and the temperature is reach up to 65 70 degrees Celsius. So in that case, motor speed is going to be decelerate, and the motor speed is going to become up to 600 rpm, 800 rpm. As per my settings, I can rotate the motor in if it's reached that temperature only. So it will help you to maintain my lifespan of the components which we have assembled or which we having in our vehicle. So it can be set by the OEM manufacturers company. Multi-mode function, as I told that, it is supportable for the dual drive system. In the dual drive system, like we are having a motor for the front wheel, for the rear wheel. So what are the acceleration speed, what are the variations? It can be extended up to 8,000 rpm. Okay, so these functions which are we are getting in the parameter function. Hydraulic functions, if we are going to enable the hydraulic function, and we having a hydraulic brake systems, so for the lift fork, for some of the vehicles, for heavy duty vehicles, then we can access through the controller as well as. Okay, our minute resets majorly we are not using. Like when our minute resets means a part where we are going to the performance of each of it will take to lift the body for upper or for the lower part. So what are the parameters are setting with the through the controller, we are going to this. Okay, let's talk about the zero speed, or you can say as a zero speed mode express. What we see that in every vehicle we are getting an option of eco speed, conventional speed, or you will see that in electric vehicle that if you are going for a conventional speed or normal mode, you can travel in the less speed, and you can cover a long distance. But when we are going for a eco mode or for a sport mode, you can say that you have to cover short distance but with a high speed. So basically what they are going to do, that they are going to change in the variable function of the motor. Okay, so when we are talking about zero speed mode, in that mode we are having to change the speed of the complete execution for the dual drive system as well as. Okay, along with that, the KPI, they having a percentage ratio up to 80%. Okay, but in that KPI, there should be a ratio, always be a 10 ratio in between of them. Okay, so while when we are going to also set the acceleration rate, just like when we are going to apply the throttle, so at what time or how much second it should be take to complete acceleration of the vehicle. So it will, when we are going to apply the throttle, it will take a 3 second to reach a complete acceleration. Okay, so as we can also set the deceleration rate, braking rate. If we in this case we always go for the deceleration rate, and the brake rate should be same. But if you are going to change the deceleration rate and the brake rate, what was happen that when we are going to apply a brake or when we are going to deaccelerate the speed, in that case, what happened? In that case, the oscillation we have feel in the vehicle. Okay, along with that, one speed mode are having a smart version part of these function only, like maximum speed, KPI, and the acceleration, deceleration speed. What are the responses, finding tuning of the low signal and high signal to accelerate the speed. These are the parameter where we are getting if we are go for the switching toward the one speed mode connection. Okay, along with that, where we are going to pump enable, threshold voltage, and time low, uh, time out, these parameters are we are getting from in that particular software. Now we are going to convert with a regenerative limiting mapping, like how much power is going to be generated in the nominal condition. What was the throttle part? In the throttle part, which type of throttle we are using? Like we are using for the sensor part of throttle, two wiper system throttle. So these types of throttle functioning we are getting. In that, what was the condition when we are going to forwarding the throttle and when we are going to reversing the throttle? So how much the ratio it should be there? What was the average voltage should be fluctuated when we are going to accelerate the motor, deaccelerate the motor? All these parameters should be changed, or also predefined functions which we are getting from the OEM manufacturers. Like the electromagnetic brakes we are going to apply in the motor, so you can set the parameters, driver main contactor parameters. Okay, like when we are going to contactor the holding voltage for the battery voltage, interlocking type, when we are going to connect with the interlocking type with the 0 or 1 mode only. If we are going to connect with one mode, so when the in the case of up healing area, or when we are going from any of the higher area to lower area, if we are going to deaccelerate the speed, sudden a brake should be applied, and your vehicle is going to initially at the at that position only. If we are going to change with the main interlock, they are having two types, 0 or 1 only. In the 0 they are going to be a normal condition, but when we are going to moving with a 1 mode, in that condition your vehicle is going to be stuck in the between of in that position only, in the between of slope. Okay, so these types of case scenario, when we are going to design the vehicle for uphilling, for off-roading, or for the mountain areas, so these side of parameters you can maybe change. Okay, so these types of option we are getting in the Curtis controller reprogrammable options. Okay, along with that, fault checking, as I mentioned, that diagnosis should be very easily, because it's having a closed loop system. So if we are going having a connection, and in the wiring harness connection only, it is very difficult to identify the fault. In that case, how we are going to analyze and diagnose the each of the components? In that case, we are having a parameters of each of the responses from the predefined library files, and then we can examine with the current status. As per that, we can easily identify that which of the voltages is beyond their average range, as well as you can easily identify value when we are getting off condition or red alert in that particular device's name. Okay, so the frequency, what are the pulse conventional, advanced conventional signals we are getting from the contactor, what was the sampling rate time. You are going to also change the sampling rate of time with the help of controller. Motor conditions, motor current, RPM, you can change the initial RPM up to 8,000 speed. Okay, 8,000 RPM. Encoder steps, along with the encoder we are having a function of smart encoder direction. So what major cases, like to shrink with the motor, many of times like we having a different channel coder. In the motor, we having a connection of UVW in AC induction motor of EVs. Along with that, they having a connections for, in that case, they having a connection for the thermostat, for the temperature sensors. Along with that, they having a 4 wires. In that 4 wires, they having a positive, negative 5 power supply. Okay, 5 volt power supply for the positive negative terminal, and two are the sensor analog signal power, where we are calling as a channel A and channel B. So in some of time, when we are going to design or to select some of the motor, the sensor is not going to be synchronized. Either you have to change the swap the conditions, swap the terminals while the manually, or you can also swap the conditions while in the prior or at the initial stage. You can swap the conditions of the wire through the software also. Okay, so we are having getting this function of swipe in encoder direction in the parameter. Encoder steps, like what are the it going to be reading, and what are the responses, the analog signals should be delivered time, like if they are getting some response, and at how much time it should be reached to the controller, and the execution, while the acceleration, deacceleration, all these ratings should be set to understand these each of the parts. Okay, again with the temperature controllers, some of the peripheral connections like temperature, hot cut back, braking thermal. If you are going to enable that, you have to set some of the parameters, you have to change the parameters. Okay, along with that, battery, we are having a nominal voltage connections. In the nominal voltage, we are getting up to a 48 volt to 80 volt power supply suitable for the AC induction motor, and in the AC induction motors, we are having stator rotors, but we having a we are not directly connected with the rotors, but with having a indirected FOC techniques, field oriented control approach, we can also change the speed as well as we can change the performance of the uh, motor operations. Okay, so these types of functions which we are getting, parameters which we are getting, emergency reverse vehicles, a metering system, interlocking braking, can interference, like we are having four connections, port for the can interference connections, to tuning the vehicle, for to connecting the ECU. Okay, for like controller, along with that we having a power distribution device, inverters, for to some of the peripheral device for the low voltage components. So you can going to connect or you can going to peripheral functioning them also with the help of Curtis control. Okay, so last part is field wicking control. Like field, as we know that in the motors, armature winding, field windings are there. And as per the armature winding, field winding, basically what in most of the prior vehicles, what we are going to do or to run in the industrial appliances, we are going to vary the speed in the field oriented. We are getting the changing in the flux, and as per that flux changing, we are getting the variations in the speed of the motor. Okay, so in that case, what we are going to do, we are having some of the peripheral functions. We are not going to change the field directly, but we are getting a change the parameters with the giving of prior connections, which we are giving a power electronics component to for the switching device, for the amplification the signals, for the pulse modulation signals, and then we are getting the output power. We are having a changing in the output power. Okay, so what was the speed? We at the last we are having also getting an option of reset the control. While if you are going, if you don't have that much efficient knowledge to get to incorporate or change the parameters, to change the logics for to analyze the vehicles, so you can also go to reset the controller to come in their initial position, and as per that you have to restart the parameter settings from each of the parameter to analyze their performance, efficiency, and in the better control way. Okay, so as we already have, as mentioned, I mentioned already that we having many of the vehicles which are using A5 controllers. Okay, but in the A5 controller and in the Curtis controller, we are getting a various differences. Like we are getting having a VCL function, which are going to be vehicle control languages. So we are easily able to reprogram their parameters and understand their performance. Okay, like we having a dual drive system, we are having some of the malfunctioning systems to connect with the CAN communication, 35 pins, and these pins are going to be performed for each of the functions like interlocking, key switching, and all these. I already cover all these 35 pins. And at last, I'm going to say that this Curtis controller is going to be giving for like for a research oriented part. It is very helpful for to understand the concept of the and the phenomena, to understand the selection of each of the components in EV vehicle. Like when we are going to design any EV vehicle in the electrical part section, we are also looking on the mechanical aspects, all with the help of mechanical aspects, gross weight of the body. We are also need a high torque from the motor to reach that certain speed, to reach that efficient convention to propel the wheel at that particular load. So with the helping of the changing in the parameters, we are getting a good command in the electric vehicle with the helping of this Curtis controller. Okay, so that's it from my side. I hope I'm clear the concepts of AC induction Curtis controller. Okay, if you have any queries regarding this, you can ask the questions.
If anyone having doubt, please ask your question. Our expert will guide you better.
सर ईव्ही गाड्यांमध्ये हेच कंट्रोलर यूज करतो.
सर ईव्ही कंट्रोलर मध्ये हेच
गाड्यामध्ये
हा
ईव्ही गाड्यामध्ये
ईव्ही गाड्यामध्ये हेच कंट्रोलर यूज करतात का?
Yes, we can use this in the electric vehicle. Okay, A5 controller and the Curtis controllers are using in the first generation model of EV like Reva, Comet. Okay.
Thank you, sir.
If you have any queries regarding this topic, you may ask the questions. I'm open the door for the questions. So I think no more questions related to this. I think AC Induction Motor Controller Curtis will give you a broad idea. Go through them. Just go once the architecturing to understand the complete concept of Curtis. Okay. So I'm ending the session from my side. So please concern team take the call from here.
Thanks for hosting the webinar. Your expertise and insights were invaluable for our learners. I would like to take the opportunity to introduce our company ISI India products and services that we offer in EV technology with a small video. So kindly have a look on video.
As we are living in the fast-changing world of electric vehicles, ISA India is leading a tech organization, paving the way for innovation and devotionalizing the ecosystem. It is bridging the gap between industry and academia and bringing all the stakeholders to the same table. From 2013, our parent organization has been tirelessly working to create an ecosystem for skill development, research, innovation, and entrepreneurship in the electric vehicle industry. Through CSR skill development and partnership with GIZ, Tata Technologies, Bharat Crop Science, Kalika Industries, Chalna Jan Seva, Masiya, IPCA Laboratories, etc. And with national and international e-mobility events such as Electric Solar Vehicle Championship, Formula Imperial, Indian Karting Race, E-Bike Design Challenge, we have provided a platform for over 3 lakh students from more than 750 colleges and universities to come up with the innovative projects. In addition to this, we are offering various skill development programs, faculty development programs, corporate trainings, and spectrum of courses with duration from 9 to 12 months with live and recorded interactive classes, with the added flexibility of paying after course completion. For our contribution towards building sustainable way forward in EV, we have got recognitions such as the National Youth Award from Ministry of Youth Affairs, Government of India, Titans of Technology Award, EDN Star Award from Earth Day Network USA, and the Social Entrepreneurship Award. And we have also joined hands with Automotive Skill Development Council, All India Council for Technical Education, National Skill Development Corporation, Ministry of New and Renewable Energy, and various automotive industries, which validate our global impact and commitment towards excellence. We are now a global partner for talent nurturing in the automotive industry. We are fostering the youths for the global EV market and have recently joined forces with partners in Malaysia, Indonesia, and South Africa. According to the economic survey, in India, the market for electric vehicle is expected to grow really fast, about 49% every year from 2022 to 2030. This means we could see 10 million electric vehicles sold every year, in which led to 50 million direct and indirect jobs by 2030. We are committed to sustainable mobility solutions and our industry-aligned programs cater academia, industry, and government sectors. Our expertise in the industry has led us to design cutting-edge technological solutions for the growing electric vehicle industry. We promote project-based learning, hands-on training, skill development initiatives, vocational training, research, entrepreneurship, public-private partnerships, awareness and outreach programs. Our state-of-the-art facility, the Center of Excellence for Electric Vehicle, is dedicated to spreading the word about electric vehicles by facilitation of technological advanced solutions. EV Tech Lab. It's a high-tech lab designed for students studying engineering, ITI, and polytechnic students getting job training. Think of it as a space where creativity meets actual hardware solutions. People here get to dive deep into the physical part that make electric vehicle work. This model is also helping our partners for community skilling of various job roles, such as electric vehicle technician, vehicle assembly operator, charging station operator and technician, and workforce for electric vehicle powertrain, battery and BMS maintenance, etc. Second model, that is the Center of Excellence for Electric Vehicle. It's a combination of labs and offering both hardware and software solutions, under which we have established end-to-end solutions for electric and hybrid vehicle design, powertrain, battery and BMS, EV charging, IoT for experimental learning, testing and prototyping. The solution we are providing is unique and help our learners for upskilling, research by getting experimental data and plotting graphs. Our goal is to impart industrial knowledge by establishing pioneering center of excellence. These centers, developed in collaboration with universities, industry partners, and government entities. Our COEs provide integration of EV curriculum in BTech, MTech, and other academia programs. Research and vocational NSQF courses align with the national education policy. Plus, our COEs also support the startup ecosystem by providing facilities for design, prototyping, and product testing. Our labs are making difference. We have established several labs across strategic locations with all kind of stakeholders like industry, Hero Motocorp, with Government of Kerala in partnership with MG Motors at 2 locations, IIT Mandi, private universities like SRMU, Calcutta's University, Sharda Universities, an NGO with Govardhaniko Village by ISKCON Temple, and various top universities and institutes across India. Our commitment to excellence is unwavering, and by 2025, we aim to establish over 250 plus Center of Excellence worldwide. With India rapidly moving toward an electric-only future, ISA India is well positioned to develop the workforce prepared for the international arena. Join us on this electrifying journey towards a sustainable and innovative future.
Thanks for watching the video patiently. So don't miss out on this opportunity to discover the endless possibilities of EV. So any of you want to enroll in this program, kindly send us inquiry through a QR code displayed on your screen and take the take your first step towards a more sustainable and exciting future. Thank you. And also we are having the exciting offer on the occasion of Navratri, so we do have the flat 40% discounts of offers over the program, so kindly visit our website and take the advantages also.
For any course inquiry, please scan this QR code. Our executive will call you in 24 hours. Thank you for joining this webinar. If you have any query, please scan this QR code. Our executive will call you in 24 hours.